Hey guys, welcome to 6.5 Video Notes, where we're looking at non-proportional relationships. So how can we identify if a relationship is non-proportional, and then how can they be represented as a table, graph, and equation? So this example says FitLife Gym charges customers for each month of a membership as shown in the table below. Use the information to complete A through B. So it shows us that the Y variable is your cost, and I always tell you that money is going to be on your Y variable, and number of months or time is your X. So number of months is my X, toss is my Y. So first, I'm going to pause the video and let you sketch these 4 points on your graph. Go ahead and do that now, please. All right, so there's what your graph should kind of look like. And then now you need to think back on 6.3. What do graphs look like if they have a proportional relationship? Your first instinct was they should go through the origin. Does this go through the origin, 0, 0? No, it does not. So that's our first reasoning when we explain why the relationship is not proportional. So the relationship is not proportional because it does not go through the origin. Is it a straight line? It is a straight line, so that's not a reason why. But what about the y over x value? We know that all proportional relationships and their graphs, you can write it in the form of y equals kx. So does this have a common k value? Well, let's check it. Y over x, 30 divided by 1 is 30, 50 divided by 2 is 25, and 70 divided by 3 is about 26.3. So that's not correct. So they do not have a common k value. So that's another reason why. So in addition to not going through the origin of 0, 0, the ratio of y over x is not constant. So that's our second reason why. Okay, so a relationship of any non-proportional relationship is the ratio between the two quantities is not constant. So the ratio between y over x has to be constant to be proportional. And so this example does not. All right, let's do some vocab words here. So non-proportional relationships with tables and graphs. All right, so non-proportional relationships for tables. The ratio of y over x is not constant. We just talked about that. It does not contain the point 0, 0. And when x is 0, y is a non-zero constant. So what that means is if we look back at our table here, 0, 10. 0 is my x, but y is not 0. It's any number but 0. So that's what all that means, is a fancy way of saying it's not 0, 0. So y can be any number except for 0 in a non-proportional relationship when x is 0. An example here, x is 0, but y is not 0. So I know this is non-proportional. Okay, so now let's look at graphs of non-proportional relationships. So the line will not pass through the origin, similar with tables. Instead, the graph will cross the y-axis at a point known as the y-intercept. So where the graph hits the y-axis is called the y-intercept, and that will never be 0 in a non-proportional relationship. All right, let's look at number 1. So I want you to graph these points for number 1 for this example. So we're just plotting the points for the cost for the amount of hours you're jumping at Terrific Trampolines. Go ahead and do that now, please. All right, there's your graph for number 1. So ask yourself, is this proportional or not? Well, does it go through the origin? Nope, doesn't go through the origin. And if you do y over x, 8 divided by 1 is 8. 10 divided by 2 is 5. So the ratio between y over x is not constant, so not proportional. All right, do the same thing for number 2. Plot your points and graph it. All right, there's your graph for number 2. We connect our points. Does not go through the origin of 0, 0, so not proportional. All right, flip it over. All right, number 3 says, at Pizza Palace, Rashid orders a pizza that costs $8 plus $2 per topping. Complete your representation to show the relationship between the number of toppings x and the cost of pizza y. Then answers A through D. So they tell me that my number of toppings is my x and the cost of the pizza is y. So we need to fill out this table and kind of show our work and how we can figure out what the cost of the pizza is based on how many toppings. So first, if I have 0 toppings, how much money am I paying for this pizza? Well, I'm multiplying 2 times 0 because we're getting 0 toppings, and I'm adding the cost of the pizza, which is $8. So that pizza would cost $8. What about a pizza with one topping? Well, 2 times 1 plus 8. 2 times 1 is 2. 2 plus 8 is 10. Go ahead and fill the table out with the rest of these three numbers with three different toppings. All right, there's your work for the table for the last three values for toppings 2, 3, and 4, and you get $8, $10, $12, $14, and $16 for the pizza with those many toppings. So now go ahead and take a second and plot your points on this graph. All right, there's your graph. So now we need to figure out what is our equation. Okay, so what's happening? Like, what's changing? Do I have a constant? What's being multiplied each time? You should know that it's $2 per topping. And if you look at your change in your y value, what's happening with the change in the y value? It's adding 2 each time. So what's my common rate of change, or my k value? Well, so I don't want you to think it's your k value, because only proportional relationships have your k value. But this is going to be your rate of change. What's being added each time here? It's going up by 2 each time. So if your equation, it's going to be 2x. 2 times the amount of toppings you have is represented by 2x. And then what am I adding to 2x? Look at your process box here. We added 8 each time because the pizza costs $8 no matter how many toppings. And then you add the multiplication step of how many toppings you get. So it's 2x plus 8. That's how you can write your equation. All right, now let's answer these questions here. A, what is the initial value or the cost of the pizza with 0 toppings? So when x is 0, that's what it's asking. When x equals 0, what is y? That's all it's asking. Well, if you look back at our table here, when x is 0, which is toppings, your y is 8. So I want you to answer B, C, and D now. I'm going to pause the video. All right, we'll talk about B here. So it's asking you from each representation, table, graph, and equation, where do you see the initial $8 coming from? So from the table, you see the initial cost of the pizza with 0 toppings when x is 0, 0 toppings. For the graph, it's your y-intercept. It's when x is 0, what is y? It's right here. You start at 8, 0, 8. And then for the equation, it's your constant. It's what you're adding to the 2x. Okay? What about C? What is the rate of change of the situation? The rate of change is the number in front of your x value. It's not your k value anymore because that's only for proportional relationships. We call this the rate of change when it's not a proportional relationship. So your rate of change is 2. It's $2 per topping. And D, where do you see the rate of change in the equation? It's the coefficient of your x variable. Okay. All right. Number 4 says, Mr. Teen asked his students to create representations of non-proportional relationships. Which students correctly completed the task? Explain your reasoning. I want you to look at Ellie, Gary, Cedric, and Sina's examples and circle the ones that are non-proportional. All right, guys, check your answers with me. So Ellie created a proportional relationship because you get a k value of 10.5 for all these values, so that's not proportional. Gary added a constant at the end. So this is 3x plus 2, so that is not proportional, so I circled that. Cedric only has y equals kx form, so your k value would be 2, so this is proportional. And Sina created a graph that does not go to the origin, so that is non-proportional. Okay, I think you guys are ready to go do the mastery check. I'm going to pause the video, and we're going to skip number 5. So go ahead and do the mastery check and the must-do. Obviously must-do first. Good job, guys, with completing 6.5 video notes.